Hello friends, welcome to my YouTube channel. Now, in this session, I would like to solve the previous Mahatransco electrical engineering paper. So this is paper is given by our YouTuber Suraj. So thank you Suraj. So now we'll start our session here. So the questions which I am taking here is our technical questions. I'm not discussing any non-technical questions such as aptitude and some other. Now the first question that we are hearing is which of the following torque armature current IA characteristics is it true for a differential compound motor. So if you draw the characteristics in between the torque and armature current, first you will find this is as a cumulative compound motor. So cumulative compound motor characteristics, and second one is this rising characteristics are for DC series motor, and third one is differential compound motor, and fourth one is for DC shunt motor. So in the given options, the correct option is third one, that is differential compound motor. So next question, in bipolar junction transistor, the type of configuration which gives a both voltage gain and current gain is same here. So in this configuration, so only the common emitter configuration will have voltage gain and current gain both are same. That means they will give the medium gains. So the medium gains is, the option is C configuration. And the next one, 83rd one, the dielectric strength of air at natural NTP, natural thermal point, is nothing but it is 30 kilovolts per centimeter if you are discussing about maximum value, and if you are discussing about RMS value, so 21.1 kilometers per centimeter, so this is RMS value. So in the given options, 30 kV per centimeter is the right answer. Next one, synchronous condenser means an overexcited synchronous motor operating at, so operating with, the options is no load with leading power factor. So leading power factor can be used in large power stations for improvement of power factor. An overexcited synchronous machine during no load condition is act as a power factor improvement. So power factor condenser say. Okay, so here at no load, as a full load, no load and leading power factor. So next question. So here, this is from power electronics. Which of the following is or not true with reference to a thyristor? So which is not reference. So latching current is associated with a turn off process. So the actually latching current is associated with turn on process. As my in previous lectures you can see this turn on process, and holding current is associated with turn off process. So first statement is wrong. Next one, holding current is associated with turn off process, right, and latching current with the turn on process. So this is also right. Next one, a thyristor is termed as AC switch. So this is wrong. A thyristor or treated as SCR is a DC switch. Why? Because it will have the blocking capability. That is, it will have reverse blocking capability. So forward blocking capability, forward conduction capability, but not reverse conduction capability. That's why treated as DC switch. Suppose if you want AC switch means we'll go for triac. So in triac, it will can be used for all four modes of operation. So reverse blocking, reverse conduction, forward blocking, forward conduction. So triac is considered as a AC switch, AC is considered DC switch. So in the given options 1 and 3 are wrong. Okay, so here which is not true means you can go for, so in the given options only 2 is the correct one and the remaining things are not correct. Next question, the more dominant property in cable is the following. So in the given, the more dominant in a cable is, it's a capacitance. and more dominant in transmission line is, overhead transmission line is, it is inductance. So the option here is, it is capacitance here. Okay, next one. Generally the characteristic impedance of a cable is taken as, so characteristic impedance of a cable is 40 ohms. Suppose characteristic impedance of OHTL over transmission line is 400 ohms. The option is 40 ohms. Sorry, 40 ohms here, not this one. Next one. Next one. Which of the following statement is are true? So superconductors have almost zero resistivity. The external magnetic field has no effect on superconductors. The beryllium ferrite can't be used for permanent magnets. So in that one, the superconductors have almost resistivity is a true one, but remaining two are false statements. Why? Because according to Faraday's law, whenever a magnetic field cuts the conductor, an EMF is induced. So here superconductors means EMF also induced here. So the statement is wrong, and this one is also wrong statements. So only one is the correct one, is the answer here. Next one. Find the discharge if the power developed by hydroelectric power plant or generator unit is 9.80 kilowatts, and assuming 100% efficiency with a 1.0 meters head, and density of the water is taken as 1000 kg per meter cube. The formula for this question is, so power developed with hydroelectric power plant is equal to P is equal to W, Q, H and eta here. So here the W is the density of water, it is nothing but it is 9.81 kg per meter square, general value. So Q we need to find here, and head is given as 1 meter, and efficiency is 100%, and P is given as how much watts? 9.80 watts. So from this we can substitute Q is nothing but 9.80 kilowatts divided by 9.81 kg per meter square into 1 into 100% means I can write 1. So this is approximately equal to, so 1.0 meter cubed per second. The answer is this one. Next one. Which of the following cases Ferranti effect on long overhead transmission lines cannot be expressed? So Ferranti effect is nothing but in a transmission line, so says generator here, and here we have load. So Ferranti effect is nothing but under light load conditions or no load conditions. So no load or lightly loaded conditions. Suppose a sending end voltage is say 230 volts, receiving end voltage under light load conditions it may be around 235. That means the receiving end voltage is more compared to sending end voltage during no load conditions or lightly load conditions. This is nothing but Ferranti effect. So this cannot be expressed when the load is heavily loaded or power factor is unity. So 1, 2 is the answer. So both 1 and 2. So when these two cases are satisfied, we cannot see the Ferranti effect. That means receiving end voltage is more compared to sending end voltage. Okay friends, we'll continue our discussion on next session. Thank you. Have a nice day.